Hi everyone, I will present to you our group's this project, GeoExplainer, a visual analytics framework for spatial modeling, contextualization, and report generation. We usually need to train a spatial model to analyze the spatial relationships and discover interesting patterns. In the model training stage, select proper input variables for model is very important. In a conventional geographic information system like ArcGIS, although these systems are versatile, there is no explanation or suggestion to guide analysts for the variable selection. Popular spatial analysts library like Python also needs analysts to build their own model training pipeline by using different packages and writing code. Analysts need to well understand the features of the input spatial data in order to select the variables they need before training the model. Although these conventional geographic analysis systems usually support rich spatial model calibration tools or packages to help analysts configuring the model, they do not support contextualized explanations. These systems require analysts to carefully choose the appropriate tools at every stage of the analytical pipeline and understand what's going on when build a well-trained model. This process needs a solid foundation in geographical concepts and can be time-consuming, even for seasoned analysts. GeoExplainer provides interpretable parameter recommendations to guide analysts to appropriate model configurations. By closely collaborating with domain experts and spatial model developers, we distill the most common functionalities for configuring a spatial regression model. We use narrative visualizations to support interpretable model parameter selection. In the model configuration stage, GeoExplainer embeds inline visualizations and annotations in well-coordinated interactive panels to enhance the usability and usefulness. The detailed feature analysis view provides an annotated histogram with details on normality and skewness tests, as well as an auto-generated text annotation illustrating the data distribution. The text also includes interactive suggestions on appropriate transformations to apply to the data. The correlation view consists of two interactive panels. A scatter plot view shows the linear relationship between independent variable and dependent variable, and a scatter plot matrix shows the correlations among selected independent variables. Each view contains automatically generated text annotations to highlight bivariate linear correlation, which prompts analysts to consider removing redundant features. Once we train a model, the parameter estimates and diagnostics are often produced in the form of data tables. These numerical and statistical records contain heterogeneous local contextual information, which is hard to understand without background information. Most extant tools only use maps to visualize the spatial surfaces without the ability to bring in further contextual information. GeoExplainer automatically provides relevant contextual information to support explanations to the spatial analysis pipeline. We use template-based narrative visualizations to explain the data's distribution and the related spatial context information. We also link external contextual information associated with the interesting spatial patterns. Here is an example shows how GeoExplainer dynamically generates template-based explanations to interpret the distribution of the local residue and the statistical context meaning of it. This example shows how GeoExplainer explains the parameter estimate result of the young people who tend to vote for Democrats with external contextual information. The system presents the explanation of the spatial distribution, including automatically detected interesting patterns. Analysts can locate related cluster and browse the external key phrases information grabbed from Wikipedia, ranked by their weights. Original Wikipedia contents are dynamically linked with each key phrase for reference. Here, we explore the external key phrase list based on the cluster in Ohio State. User noticed Ohio University in Athens County has a higher weight. The user then selected Athens County to see its Wikipedia key phrases and found this county is a democratic stronghold. Analysts can easily search the key phrase information combined with the location information in search engine from our interface. By working with domain experts, we distill and propose text templates to generate narrative explanation in our framework. Here is the templates we use. Please refer to the paper and appendix for more details to better support the understanding and the reviewing of the explored information. Analysts can highlight, annotate, and organize their findings in the report authoring panel. All the content, including narrative explanations and visualizations, are able to add to the report authoring panel. Analysts can re-edit the content, change color scheme of the visualization, reorder the sequence, and add their own paragraphs. In addition to the spatial data analysis, the communication of the explored results and the replication of the analytical state or data or even model are also very important. The goal of spatial analysts is to answer questions about spatial phenomena and communicate the findings to a broad audience. However, the multifaceted analysis outcomes from advanced analytical tools are often difficult to interpret for a general audience. The report authoring function transforms the findings into PDF reports for a broad audience. Analysts can save, retrieve, and share the analytical state asynchronously at any point during the analytical pipeline, including the configured model, explored information, and the report. Overall, GeoExplainer provides a flexible web-based analytical pipeline that unifies the exploratory spatial data analysis, narrative explanations, and report authoring functionalities. In the case study, 2 domain experts were invited to analyze the US presidential election data. Expert 1 is responsible for configuring and training an MGWR model on the dataset. After training the model, Expert 1 saved the analytical state and shared the state with Expert 2. Expert 2 used the model analysis and report authoring components to explore the model results and author a report. GeoExplainer is a framework which supports dynamic contextualized interpretations to enhance the accessibility of the spatial modeling. It automatically identifies interesting spatial patterns and outliers from the local spatial modeling results. It's an integration of an interactive report authoring tool with a spatial analysis pipeline. All the codes are already open sourced. Here is the GitHub link. Thank you everyone for listening.